I do, actually. If you sign up to my email list. We gotta do that. We gotta do that. Okay. So what are we going to do? We are looking at the abacus. And what we're doing is we're looking at how to read it. Oh yeah, that's what it is. That's what we should do. When we are looking at it, we need to understand that this is the beam, this is the frame. So this is the frame, that's what this says, right? And then what we're going to do is this is the horizontal bar. The horizontal bar is what tracks our numbers. And then we have all our lower beads. We have all our lower beads. So we have our bottom beads. These are our bottom beads. And then this is the top bead. And then these are the top beads. What? That's so easy. Yes, it is. It is very, very easy. And so when we're looking at it, right, this is 0. When we have 0, if you notice, that's 0. None of the beads are touching the horizontal bar. Because the beads are not touching the horizontal bar, we're now, that's called 0. And then if we look, oh, so here's what it is, right? So we're just counting. That's what all we're doing. We're just counting on the abacus. When we count on the abacus, what we're doing is we're learning how to read it. So we have 1, and that's what 1 looks like. 2 is 2. 3 is 3. 4, 4 is 4. And then we have all these activities. So if I have 4 koalas, I have 4 koalas. There we go, 4 koalas. We have 4 on the abacus. That's what we're doing. We're reading the abacus. And so then, what's after 4? Well, we know what after 4 is, right? 4 is after 5. 5, hey, Dolce. Dolce, Dolce, Dolce. Welcome, welcome, welcome. So what we're doing is we're doing 5. 5. 5 will always be the top bead, no matter what. 5 is always going to be the top bead. We got that, we got that, we got that, and then we got this. Okay, good. So then this is 6. Oh, that's what 6 looks like. 6 and then 7. Notice the picture looks the same, right? 7, 7. 5, 6, 7. That's what 7 looks like. 5 and then 2 beads. The 2 beads, right, is equal to 1, and the top bead is equal to 5. And then we have 6. We have 6, 7, 8. That's what 8 looks like. 8, if you notice, is a 5 and 3. 5 and 3. First comment. Dolce was the first comment. But thank you, Steele. Thank you for commenting. I do appreciate it. Hello, Reeves. Hello, Reeves. Welcome, welcome, welcome. Welcome, everybody. Thank you so much for the heart me. All right. So what are we doing is we're counting on the abacus. When we're counting on the abacus, we did 8. That's 8. 5, 6, 7, 8, and then we have 9. 5, 6, 7, 8, 9. That's it. That's it. That's all we're doing. But if we're looking, then we're like, well, what's 10? Well, if you notice, 10 is this. 10 looks like 1 and a 0. So just as I had 1 over here, now I have 1 over here. The 0 is like a placeholder. And now we can start counting on using our columns. So we have 11, and then we have 12. 12 looks like 1 and a 2. Well, here is my ones place. My ones, my tens, my hundreds, my thousands, my 10,000. When we're looking, we have 10, 20, 30, 40, and then 50, 60, 70, 80, 90. After 90, right, we have 100. 100 happens to be on our hundreds column. Every column is a place value. So we have our ones, our tens, our hundreds, our thousands, and our 10,000. Yeah? So when we're looking, if anybody have any other comments, please let me know. But please, don't hurt people. Hurt people, hurt people.
Hey, easy. Hurt people, hurt people.
All right, so we want to be nice in this area, in this room, right? And then any questions about the abacus, let me know. Anything about counting, arithmetic, so we can do adding, subtracting, multiplication, and we can do division. Wow, that's a lot of people. All right, so what we're doing is we're going to continue on to count. So we have 1, 2, 3, 4. How does multiplication work on the abacus? Well, it just tracks our numbers. But the first thing we need to do is understand how to add and subtract. So before we can jump into all of that, we would have to put a pin in that. Let's put a pin in that, and we will have to go into understanding how to add and subtract. When we know how to add and subtract, then I can show you how do we do multiplication. Because even in school, they don't teach you how to multiply until they teach you how to add and subtract. So unless you know how to add and subtract already on the abacus, then it's golden. But if you don't, then let's go back a few steps, right? We got to take it a little one step at a time. But you can do multiplication and division on the abacus. It is possible. It is possible. Can we do it? Can we do it? Yes. All right. So the first thing we're going to do is we're going to read the abacus. We're going to continue to learn how to read the abacus. Here is a, oh, that's not it. Here's a maze that I've created to help us learn how to read the abacus. And so here's a maze. And what we're going to do is we're going to start over here. And then as we read our abacus, right, we're going to follow the path. And whatever the path will take us, we will finish. So if I have this number, and if I look, we're only doing 2 digits. So that means I have my ones, that means I have my tens and I have my ones. When we read it like left to right, just as we write in our abacus. So just like how we write our numbers, we have our tens and our ones. So if this is my tens and this is my ones, if I put this in my tens and I have this in my what number do we think this is? So when I counted, right, this is 5, 6, 7. So now we have 70. And then we have 4. 1, 2, 3, 4. That is 74. So when we're writing it, right, that's what it looks like, 74. Thank you, Cheaper Town Hall. And then we have this number. If I have my tens and my ones, when I look at it, I put my tens and I put my ones, that's what I have. What number do we think that is? And if it's just you and I, then we can go straight in. Oh, Dolce. Okay, good. Yeah, if it's just the three of us, then we can go straight into multiplication. But I just want to make sure that we understand how to read the abacus, because I don't want to get to be too confusing. If that's all right, cheaper hall. Is that all right? So let's put a pin in that, and we're going to continue a little bit further. And I'm going to do. There's a few things I want to do before we go into multiplication. But if it's only going to be the 5 of us, the 3 of us, it's going to go really quick. So we have our tens, and then we have our ones. And what number do we think? Yes, thank you, Dolce. It is 37. How do I know? Because I have 3. 1, 2, 3, and then I have 7. 5, 6, 7. And then after that, so it's going to take us up to here, and we are now over here. So I have my tens and my ones. My tens and my ones. Hey, Abba. Oh, yeah, thank you. Teaching the dog how to count on the abacus. Yeah, let me see. What happens if I do this? Can you see? No, it doesn't show. Yeah, I thought that was kind of funny too. Trying to show a little bit of humor because I like jokes. Okay, so welcome, Ileana. Let me know if you have any questions. It showed as pinned. Yeah, but it doesn't show it on my other streams. So 70, yes, thank you, Dolce. 71 because it's 75, 6, 7, and then this is 1. Yeah. Yeah, because I'm streaming on all the other platforms, and so I was trying to figure out like what I can and cannot do. I know I don't get the sound bites on my other platforms, so that's kind of sad because I really like my sound bites. Yeah. So if we have our tens and our ones, we have our tens and our ones. If this is our tens and this is our ones, we have, but yeah, thank you, Cheaper. 5 and 5. It is 55. Thank you. And then we go down to here, and here we are. So if I have my tens, and my ones. If I add this and I add that, what number do we think this is? Yes, thank you, Dolce. It is 45. Thank you, Cheaper Town Hall. Yes. Okay, good. So yeah, once we go through this, let me show you how to add and subtract, and then we can go straight into multiplication. That will be the promise, because there's only the 4 of us. So tens and ones. If I add my tens and then I add my ones, I have 35. I have 3 and I have 5. 1, 2, 3 in the tens, and I have the 5 in the ones. Comes down to here, and my answer here would be, if I have my tens, that's what tens look like, and then I add my ones, that would be that. That would be an easy number. That's an easy number, yeah? Can we do adding double digits? I'm still stuck on that. Yes, we can do adding in double digits. Yep, not a problem. We can do that. That's not a problem. Um, okay, so, Dolce and Cheaper Town Hall, we don't need to finish this. It seems like that you guys are okay. We can go straight into adding and subtracting because it just seems like it's the four of us, and Alma's been around for a while, so she knows what we're doing. Yeah. So guess what? I guess we're yeah. We'll do that. Yeah. Woo woo. Okay. Good. Good. I mean, there's no point of review if it's just the three of us. You know what I mean? There's no point. Thank you, Alma, for sharing the live. Okay. So I wanted to, I'm sorry, let me just go back to fixing, I can just do that later. Okay, I'll do that later. Yeah, from the beginning. From the beginning. Ha, yeah, from the beginning. Yeah, you were with me from the beginning. Okay, so Dolce, you said you wanted two digits. Okay, so with the two digits, Cheaper Town Hall, you're understanding how to do, oh, that's the wrong one. The first thing we're going to do is we're going to understand if we can do it, right? So one of the things we're trying to do, this is not it. Here it is. Okay. So the first thing we're going to do is we're going to understand, how to make a 5. Cheaper Town Hall. Do you understand? I don't know if you're still here. Just let me know. Put in yes if you're still here. So what we're going to do is we're going to understand, before I go into the double digit, we need to understand our formulas. Now, one of the things that we're doing is we're teaching the children how to make a 5. But why are we doing that on the abacus? The reason why we're doing it on the abacus because we have a constraint. Because we have a constraint, we need to understand how to do it. So when we have this, right, plus the 4 is equal to plus the 5 minus the 1. Now we can teach the kids, right, like add 4 plus 4, which is fine, but that's not the problem. The problem is when we don't have enough beats. So the first question would be here. The first question we have, and this is to understand what we're trying to do. So we have 3, and notice we have a constriction. I want to add the 4. I don't have enough beats to add the 4. When I don't have enough beats to add the 4, what do? I need to do some exchanges. So what's going to help is if I actually, let's say we did 3 pennies, right? If I had 3 pennies instead, right? Instead of 3 beads, let me do 3 pennies. But you know what? I have 4. You need to add 4, but I only have 5 cents. This is 5 cents. I'm not sure where you are in the world, but in America, this is 5 cents. This nickel is worth 5 cents. Because this is worth 5 cents, I'm going to give it to you. I'm going to give this to you because I have enough money. I have enough money for 4, but that's too much. So what do I need to do? I need to take away the 1. So what's going to happen is now I can do it again on the abacus. I can add the 5 on the abacus, and then I can minus the 1. Did that make sense, Cheaper Town Hall? So what we're doing is we're understanding how to make a 5. That is one of the core features that we're doing in school. What we're doing is we're understanding how to what we're doing is we're understanding this concept, and then we could do it again. And then we could do it again. Apparently there's a lot more people now. Okay. So what are we going to do? Let me continue my thought before we go back and review. That's the one thing, right? So let's go back. Okay. We have our 4. When we have 4, 1, 2, 3, 4. Let's have 4 on the abacus. When we have 4 on the abacus, right? I'm going to add 4. I'm going to add 4. When I add 4, I want to give you this. I need to add the 4. What we're doing is we're doing a concept and we're going to compound it, right? We can do it again. When we do it again, we have 2 on the abacus, right? It's the same thing. I have 2 pennies. Because I have 2 pennies, and then what's going to happen? I need to add 4. Because I need to add 4, I only have 1 nickel. I only have 1 nickel. I have enough money, but I need change. I need some change back. So I'm going to give you my nickel, right? I'm going to give you my nickel to make the 4. But to make the 4, I need to take away the 1. So it's the same thing. I'm going to add the 5, and I need to take away the 1. So my final answer is 6. Does that make sense? Is that all right? How are we doing? Hello, Gabby. Let me know if you have any questions. Okay, there was a few people that came on board. Thank you, Alma. Okay, Carrie Hunter, 113. So it seems like that we need to do a little review. Thank you, Dolce. I don't know if Cheaper Town Hall is still here, because I was talking to Cheaper Town Hall. Because I know Dolce knows this already. All right. Okay. So it seems like we need to do a little review. So let's do a little review on how to review the abacus. What we're going to do is we're going to understand how to read the abacus. To read the abacus, every bead needs to touch the horizontal bar. This is the horizontal bar. So it all makes sense. Okay, great. Okay, great. So what we could do is, I guess we'll have to put a pin in it because now there are a few more people. So what we're going to do is we're going to understand how to read the abacus. When the beads are touching the horizontal bar, that's what we're going to do. So when we look, we have 1, right? Let's say we have 1 penny. That would be 1. And then we have 2. That's 2 pennies, right? The reason why I have pennies is just to show the correlation, right? It's just to show what it looks like. So if I have 3, 1, 2, 3, then I have 3 pennies. If I have 4, right? 1, 2, 3, 4. I have 4 pennies. I have 4 beads on my abacus. 1, 2, 3, 4. I could do 4, 4, 4, 4, 4, 4, 4. These are all 4s, right? So now we have to do 5. Well, what does 5 look like? 5 is this, right? Is a nickel. So because we have 5, we got to do 5, 5, 5, 5, 5, 5, 5. These are all 5s. When adding and subtracting, would it work from left to right? Yes, I usually go left to right. I try to go right to left, but I feel like it's backwards. And so, hi everybody, my name is Lynette. I have been teaching abacus for 20 plus years. I don't have very many questions that stump me, so please ask away for any questions that you may have. Anything about abacus, arithmetic, multiplication, division, and subtraction and addition. I've been teaching abacus for 20 years. My goal is to teach the children how to use the abacus and to bring it into the mainstream world. So, thank you, Dolce. So, what I do is also I have a lot of terminologies that we use in regular math to explain it into abacus world because there's no bridge. I am the bridge. I am the bridge. Okay, so we added we added the 5. When I add 1 more, now I have 6. So when I do this, this is all 6. When I have 7, this is all 7. When I have 8, right, this is all 8. And then when I have 9, that's what 9 is, this is all 9. Oh, yes, thank you, Alma. Thank you, Alma. Please take a look at my books. These are all my workbooks that's very abacus specific. And if you're looking for an abacus, I do have it available in my shop. I'm using this one. So, is there a limit on the amount of characters? There is a limit depending on how big your abacus is because size matters. Chips. So this one is 7 digits, so that means you can only do 7 digits on it, right? Because we're including the decimals, when we include the decimals, we can only go up to 10,000. So we have our ones, our tens, our hundreds, our thousands, our 10,000. And then notice my decimal sits between the ones and the tenths. Because my decimal sits between the ones and the tenths, right? It doesn't sit on a place value. Then I have my 2 decimals. But on my 13 column abacus, I have more digits because again, size matters. Because size matters, now I can choose to have more digits. So if I start here as my ones place, then I can do my ones, my thousands, and you'll notice that I have groupings, right? My groupings is every thousands and millions. So I have my ones, my thousands, my millions, my billions, and my trillions. Now, however, if you're looking to calculate or to track the national debt, you would have to use a 23 column abacus. So, and then it goes all the way up to, I think, quadrillion or something like that. But if you start from here, and this one is kind of nice because it has a placement value for 2 decimals, just like money. But this is made out of bamboo. I do not sell this one in my shop. I do sell the 13 one because I feel like it's a little bit more useful for the bigger numbers. And then And then this is my 7 column one that I have, which I also sell at my shop. Good night, Alma. Thank you so much for your help. Thank you so much for dropping by. All right. So how are we doing? Do we have any other questions other than does size matter? Chips. I got jokes. I think it's just funny. But it matters, right? It matters because you're talking about bigger numbers. So yes, size matters. So anybody have any more questions? Well, if not, we can continue on to moving the beats and recognizing it, right? Recognizing the numbers. So does that make sense on how to read the numbers? It can be used for decimals. It just depends on which ones indicator you choose. So if I did this one, I would move all my ones over here. My ones indicator would be here. So this would be my ones, my thousands, my millions. And then I'd have my tenths, hundreds, and thousands. So yes, it's actually not the decimal, it's the ones indicator. It's like a label. So it's just like, picking up a Pokemon.
Pokemon, I choose you!
And you just choose a dot indicator. That's what it is. It's just a label. So you can choose any one of these to be your label. It doesn't matter. But it just matters on how big you think your numbers will be. Yeah? So usually for this 13 column one, I like to be in the middle.
Okay, Charizard, I choose you!
Because then I have a lot more space for the bigger number and a lot of space for the decimals. So that's what I usually do. But when we're working on the smaller abacus, it depends on what the question is. And usually I'm over here, but depending on like space of like the camera angle and all this and that, sometimes I'll work it here. Some people get confused when I jump between the two, but realize this is an indicator. It's a label. Realize it's a label, and you can move it around, right, just like everything else. So we're moving it around. That's why sometimes I do this or sometimes I do this, right? All right, so that's a good question. What else do we know how to read the abacus? Are we okay with that? Are we going to continue on? So how do you represent no? Well, think about it. If it says 2 5s, right, if it's 2 5s, then it's 55, right? 5 5. That's what 2 5s look like. That's what the 2 5s look like. What does 10 look like, right? 10 looks like what? 10 looks like a 1 and a 0. So exactly what you're reading is exactly how it looks. So you said 1 0 and 1. 1 0. That's what 10 is. Quiet. What do you want? No. 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 All right. Yeah. Exactly, Jay. Yeah, 1s and the 10s and 0 and the 1s. Exactly how we read is exactly how we write. So just as we did to 11, right? If we had 11, it would be 1 and 1. If we had 12, right? If we have 12, it would be 1, 1, and 2. Easy. Simple to use, easy to understand. Right? Thank you, Jake. Thank you, Jake. That was really good. That was really good. But yeah, it makes sense, right? It's not it's once it's broken down, it's pretty easy. But the big thing is to understand how to read the abacus. Once you learn how to read the abacus, then we can do adding, subtracting, and multiplication and division. And so a lot of people that came in was when I was working on a addition problem. And so then I just went back to do a review. So, how are we doing? Does that make sense? We can do the maze. Excuse me. So here's my maze, and if anybody's interested, I have this maze where we're doing is going to do some bead recognition just to make sure that we understand how to read the abacus. So here is my maze, and oh yeah, I'm over here. I did that one. So if I look at this and I'm only doing 2-digit, what number do we think this is? Now, if it's only 14 of us, we might be able to push through all the way to multiplication. Thank you. 25. Wow, that's really good. 25. Yes, because I have my 10s and my 1s. 25. Thank you. Hey, Mara. Thank you so much, Jake. Thank you, Cheaper Town Hall. I apologize for going backwards. We'll have to hit it faster next time. So here we have our 1s and our 10s. We have our 10s and our 1s. If I have my 10s over here and I have my 1s over here, what number do we think that is? 35. 4. Thank you. Yes, thank you. 34 comes down to here, and then I have this one. So, thank you. Thank you, Joyful. Thank you, Famara. Thank you, Aligner. Yep. And then, if I have my 10s and my 1s, I have my 10s, and I have my 1s, so I have my 10s. Now remember, I have 5, 6, and then I have here 5, 6, 7. Thank you, Cheaper Town Hall. Yes, exactly, right? Easy? Almost, almost. 77 looks like this. That's what 77 looks like, because it's 5, 6, 7, and 5, 6, 7. So when we're looking, we want to do a 67. We have one bead on the bottom and one bead on the top. So that's 67, and our final answer is, oh, can we read that? Our final answer is, that's amazing. Oh, thank you so much. Oh, it is available if you're looking for more mazes, because I like mazes. If you're looking for more mazes, and it's only doing bead recognition. So what we're doing is we're just learning to read the abacus. And so we have this number. What if this is, thank you, Travis, thank you. Thank you, Jake. So what we're doing is this is my 10s. There's nothing on my 10s. And then this is my 1s. It is 9. How do I know? 5, 6, 7, 8, 9. And there we go. That's it. All right, we're done with that. So now we are understanding how to read the abacus. When we understand how to read the abacus, the next thing we're going to do is we are going to move the beads, right? And so that's where we were kind of left off at. Thank you, Joyful, for the answer. So again, what are we going to do? Well, we have already done our, we've already done learning how to do some bead recognition. So what are we going to do now? What we're going to do is we're going to understand how to move the beads. We do not want to be aggressive when we're moving our beads. We don't want to be aggressive. We want to be gentle. We want to be happy, right? We want to be gentle and we're happy. So if you look, right, if you look, notice that when I'm moving the beads, I'm moving just the edges of the beads. So if I have 2, I'm going to do 2. If I have 4, I'm going to do 4. Notice I'm just like lightly touching the edges of the beads. So when I do 6, I'm just doing this. When I do 7, right, I do this. When I do 8, I do that. Oh, that's 9. This is 8, right? But again, you want to be gentle. You want to be gentle. It's my first time knowing how to read the abacus. I was always confused. Oh yeah, yeah. It's not very difficult to read, but then again, it doesn't take. It takes. It showing how to read the abacus is a skill in itself. So that's the thing. So what you want to do is you want to make sure that you're only using and it's very easy, right? It's very easy to move. It's like a rattle. But notice it's very easy to move. So if it gets bumped, then your answers are going to get wrong. So you need to use your left hand to stabilize the abacus. Your left hand stabilize. Right hand does the calculation. Because they said something like the left hemisphere does the calculating. I don't know. It is what it is. But so then that's the one thing. But then notice that, let's say I have my question right, and if I do this, I flicked too hard.
And flick. Oh, you flicked too hard, damn it!
Don't flick too hard because you're going to get the wrong answer. Okay? So what I want to make sure is understand you're just going to move it. You're going to be intentional and you're going to be gentle. So when we're looking at it, we want to be, the same. We don't want to flick. And you'll notice that sometimes my answer will become wrong because I'm moving the beads or I'm moving the bead of the abacus too much. So if I'm doing this right too fast, then all my answers will be wrong. This is a standard size abacus. No matter how big and burly and pudgy your fingers are, you should be able to move them. Just as this is also a standard size abacus. The only difference between is that this is colorful. The color means nothing. They're all the same colors. It's all about the position of the beads. So if the beads are touching the horizontal bar, that's what's being counted. When the beads are not touching the horizontal bar, then this is all 0. Does that make sense? So what we're doing is we're understanding how to move the beads. Now we're at the point where we want to move one bead at a time. The question will always be, the question is what? In abacus world, right? In abacus world, what we're doing is we're understanding what the add-in is. Do we know what an add-in is? An add-in is a number that we add to. So in abacus world, we're not looking at the result. We don't want to marry. We want to marry the process and divorce the result. So what we're doing is we want to understand the add-in, right? We're not looking at how do you make an 8. We're not doing that. What we're going to do is we're going to look at the add-in. Can I add a 2? So if I have my abacus, I have 6. We know that this what 6 looks like. 5, 6. The question is, can I add the 2?
This is the way.
Yes, we can. Yes, thank you, Macheta. 2, we can add it. So we have the 2 beads and we add 2. So my final answer is 8. How do I know? 5, 6, 7, 8. I just count what I have, right? So it's the same thing with the 2 plus 2. 2 plus 2. That's too easy. That's 2 plus 2. Okay, whatever. So then we could do 5. When we do 5, we have enough, right? Can I add another 3? Oh, can I add another 3? Yes, we can. We can add a 3. Notice I'm not saying how do you make an 8. What I'm saying is, can I add a 3? You could, if you really wanted to, be like the mainstream and just start doing dots. You could do that. That's up to you. But I'm teaching you how to do it through the abacus way. Thank you, Chips. Thank you, Is Cheese. Welcome back. Welcome back. So what we're doing is we're understanding our add-in. Our add-in is adding the 3. When we add the 3, what we're doing is we're moving 3 beads. It actually doesn't matter which 3 beads. If I have 1 already and I want to add the 3, I have 3 beads. It doesn't matter which 3, just it needs to be 3. That's it, right? So what we're doing is after that we need to do 4. Now notice when I'm adding, I go to the horizontal bar. That's what adding is, right? Thank you. This is too fun to not come back to. I get some more sound bits. I like this one when somebody trolls me.
Hey, easy. Hurt people hurt people.
I gotta work on that one a little bit. But I like that one. I was watching Bullet Train, and it was like hurt people. And I was like, oh, that's brilliant. Thank you, Macheta, for following me. Okay, so what are we doing? Remember, when we're adding, we go to the horizontal bar. When we're subtracting, we want to go away from the horizontal bar. So if you notice, I just did a subtraction. If I want to add the 4, that's what I do. I want to minus the 4, that's what I do. So when we're adding, we know how to subtract because it's the same thing, just the opposite. When I have 2, I'm adding 2, but then I need to take away 1. When I take away 1, I'm just moving it away from the horizontal bar. That's all I'm doing, right? Make sense? How are we doing? We're all right? Okay, so we're done with that. So I'm moving with this one. And anybody interested, I do sell this abacus available in my shop. And then a 2. So if we have 3, again, what we're looking is not the, well, I call it a add-in, but it's actually a subtract head. So hopefully we can see that. So then we have to do is it's the number that we're subtracting, right? So can I take away the 2? Can I take away the 2? So I take away the 2. My final answer is 1. Again, what we're doing is we're marrying the process and divorcing the result. We want to make sure we get the result correct. So what we're going to do is we're going to do 4. We have 4, and then we want to take away the 3. When we take away the 3, interesting. When I take away the 3, I just take away these 3 beads. So it's the same thing. And then we can just keep going through. It's the same thing with the 5. When we add the 5, when we add the 6, I added the 5, right? And then I added the 6. Now, if you notice, if I have 1 and I need to add the 6, I'm moving these 2 beads over here. I'm adding these 2 beads. If you notice, right, if I take away 6, I just move it away like that. So if I had 2 and I want to add 7, I move these 3 beads, right? And then if I want to take away, it's these ones. 1 bead on top and 2 beads on the bottom. That's what adding the 7 and taking away the 7. It's the same thing with the 8. It's exactly the same thing with 8. So when we do 8, that's what 8 looks like. We take away the 8, that's what take away the 8 is. Yeah? It's still 7. Yeah. 8 minus 8. Thank you, Machete. Yes. So then we did 9 and then minus 9. Right? 9 minus 9. Okay. So that's it. That's it. So what are we going to do? Well, what's going to happen is what happens when there's not enough? That's where I was actually, okay, this is where we were, right? And then everybody started flooding in. I was like, oh, great. So what are we doing? We're going to a point where what happens when we don't have enough? We don't have enough. What does that mean? Well, here's the question. If I have 3 on my abacus, I don't have enough. I don't have enough to add a 4. So what do I do? So let's do a review, right? If I have 3 pennies, I don't know where you are in the world, but in America, 3 pennies. These are all worth 1 cent. Because these are worth 1 cent, I have 4. I need to add the 4. But to add the 4, I only have 1 nickel. I only have 5 cents. So what am I going to do? I'm going to give you my nickel, but I need change back. So I need to take away the 1. So what's going to happen is it's going to look exactly the same on the abacus. I'm going to add the 5, and I'm going to take away the 1. So my final answer is 7. 5, 6, 7. 5, 6, 7. How are we doing? Is that all right? So we could do it again. If I had 4, and I add another 4, I don't have any more pennies. What I'm going to do is I have a nickel. A nickel is worth more than 4, right? So I'm going to give you the nickel. When I give you my nickel, when I give you my 5 cents, I'm going to give you my 5 cents. But that's too much. I need to take away 1. So when I take away the 1, my final answer is now 8. Again, what I'm doing is I'm focusing on the thing that we're either adding or subtracting. Does that make sense? So when we're looking, we want to know this. We don't want to know what the result is. We don't want to know what the answer is. What we want to know is, what are we trying to do? We're trying to add the 4. So when we try to add the 4, let's say here's another question. Let's say 2. So if I have 2 on the abacus and I want to add another 2, add in 4, but I only have a nickel. Because I only have a nickel, I'm going to give you my nickel, but that's too much. That's too much. So I'm going to add my nickel, but I need change back. I need to take away the 1. So when I take away the 1, my final answer is now 6. Does that make sense? We can do it again. What does that mean? Well, now we've done it with the 4. When we're making the 5, these are the ways we can make a 5, right? We can do it with the 3. 3 and a 2, right, can make a 5. So we do it again. We have, let's do 3 plus 3. So if I have 3 pennies on my abacus, I have 3 pennies. I have 3 items on my abacus. When I have my 3 items, right, and I need to give you 3, but I only have a nickel. If I only have a nickel, then what do? I give you my nickel because that's enough, but that's too much. So if I add the 5, I need to take away 2. I need to take away the 2. So my final answer is 6. Joyful. So in any abacus, above the horizontal bar is always counted as 5. Yes, exactly. Exactamundo. It doesn't matter which abacus. Actually, I take that back. It doesn't matter if it's a Japanese abacus or a Chinese abacus. So in a Chinese abacus, it works very similar. This is a Chinese abacus. This Chinese abacus, the top bead, if you want to be poetic, is called the heaven beads, if you want to be poetic, right? Same thing with the Japanese, right? All the bottom beads are called earth beads. And this is worth 5. So we can count it. 1, 2, 3, 4, 5. This is 5. What we're going to do is we need to do an exchange for this. So if I have 5 here, I'm going to exchange it to do that. That's what the exchange is. What we're doing is we're counting on the Chinese abacus. So when we're looking, we have 5, and it was 6, 7, 8, 9, and then 10. And again, we need to do an exchange. We do this, and now we have that. That's 10. But then because this is 10, we have to do an exchange. That's 10. I don't sell this. I'm just using this as a demonstration. So we can still count, right? 10, 1, 0, 10, 11, 12, 13, 14, 15. Oh, hey, 15. We can do another exchange. That's what 15 would look like. So then we have 15, 16, 17, 18, 19, 20. Yeah? Joyful, would that make sense? What's the highest number you can display at one time? Anything with a 9. So this one specifically would be 999,999.99 because it's only 7 columns, right? However, if I have a 13 column one, then I have trillions because size matters. So then I would have 19 trillion 999 billion 999,999,999. Yeah, it's the Chinese one is only unfamiliar. That's what it is. It's just unfamiliar. Hey, Aura, welcome back, welcome back, welcome back. However, if I had a 23 column abacus, and I know another person has a 27 column abacus, it'd be the same thing. It'd be 99 quadrillion 999 trillion 999 billion 999 million 999,999 whatever. You know what I mean? So it all depends on the amount of columns you have. Because size matters. It all depends on what you're trying to do with it. I mean, obviously, 27, 23 columns is a little. To me, is a little bit of overkill because our numbers never get to this big, right? So, yes. Hello, Aura. Yeah, makes sense, Machete. Yeah, cool. Okay. So what do we do? Oh, we're doing this. So when we're doing the making of the 5. When we make the 5, right, we understand how to make a 5. When we make a 5, we make a 2. We could do the same thing. Oh, that's not good, right? But notice that if you can make if you make a 2, if you make a 3, you can make a 2. How about the horizontal one where you count from left to right? I specifically don't have a horizontal ones, but I can explain it. And if you have one, Chris, if you have one, you can modify it. But the way it is done on that one is just it's a 1-to-1. So we have 10. We do 10. So when it's like horizontal, all it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. How old is your child? It does depend. The cubes. um, the hair chemist. The hair chemist. It depends on how old your child is, right? If your child is like 3, 4, and 5, I have a preschool one. Um, because it helps with. He's 10. I would recommend going into, if he's okay, I would recommend him going into learning how to read the abacus. That's what I would do because he's 10. And this is a little bit more fun than coloring because the preschool one was meant to for young kids to understand how to read and what the relationships are. So the 10-year-old, I would probably go straight into here where you would take the maze and you understand how to read the numbers, and there's instructions as well. So here I give you instructions on what the numbers read, and then after that you go into understanding the how to read it. So then after you understand how to read it, and then this one is the reverse maze. I also give a reverse maze where I give you the number. I'm sorry, I give you the number, and you're supposed to color it in. So here, if we start over here, I give you the number. We look at 45, and you got to color it in. So here I color it in. And that's what I did. This is what I call a reverse maze. And then this is just to get them to get used to how to read the abacus because it's a little different, right, than the blocks. So, and then after that, I'd go into adding and subtracting, how to add a 5 and how to make a 5. This is gonna he'll blow through it really quickly because the thing is show the cover for me on the screen. Oh, you know what? I have it in I have it on my TikTok shop. I have this one, and then I have the other one. So after this one, I would recommend going into this one. This should not take a month. It should take him maybe 2 weeks because there's a fair amount of activities. And so that's what we're doing right now is we're going through, and what we're doing is we're understanding how to make a 5 because we know how to make a 5. This one is the plus 5. After you know how to make the 5, you're going to have to subtract the 5. Everybody starts from the fundamentals, no matter what grade, how old we are. I had to start from the fundamentals, and I started when I was 30. I've been teaching abacus for 20 years, and so everybody starts from the fundamentals. It just depends on how it's being presented. So this one was trying to get them to understand like how to make a 5 and how to use the formula. And then I have like activities to go with it. So like there's like word problems, and then there's another maze. You answer the maze and you follow the path, and then there's tic-tac-toe. And then after that, it's just more hidden words. So then here there would be the word that they would have to try to figure out. So and then there's answers, just in case we're kind of lazy. But there's answers. Hopefully the answers are matching. But then after that would be minus the 5. After minus the 5, then it'd be plus the 10. After plus the 10 would be minus the 10, and then you mix the two. So there's a whole framework and progression that we do in Abacus. And so and I'll show you the overview. So this is the overview of the Abacus framework. The first thing we did is we understand what it looks like. Then the second thing we did is we needed to know how to move the beads. That's what I was showing you. The third thing we did is understand how to add the 5. Because we have to add the 5, then what we do is we're going to add the 10. Right? Because that's what we do in the Abacus world. In mainstream, we do adding the 10 as well. They focus on adding the 5, but there's not understanding why. I haven't received or understood a really good reason why mainstream math is teaching how to make a 5, but in Abacus, it is one of the pillars that we need to do. RTX, welcome. A Dreamy, is it a faster way to memorize math? It is faster. It's faster to understand conceptually. So when we're doing our the formulas, we're understanding that we need to add the 5 and take away the 1. And then what we do is we do critical thinking, because there's a whole process and a workflow that happens when we start adding and subtracting our numbers. And then as the numbers go through, so there's a bunch of things like I know in mainstream math there's a lot of strategies like make a number friendly or memorize your doubles or so forth and all this and that. Whereas in Abacus, you know this, that's it. You just need to know how to use it. So I'm getting one for my 7-year-old also. The 7-year-old, yeah, okay. The 7-year-old would still, I think, would still be benefit to come to here first, just because it's just looking at the beads, right? Again, the 7-year-old already knows like the relationship of the numbers. Already know of the numbers. Okay. Hey, Neon. Which schools in the U.S. use the abacus? I don't know. That's what I'm trying to do. I'm trying to bring abacus to America. There's a couple of here and there, like I've been told, but I don't know. It's been Abacus has been regarded as a enrichment program, but I feel like the Abacus is more fundamental than just because I don't know if anybody's heard of Singapore math. It's along the lines of Singapore math, but it's more granular. So what Abacus does is it gives you the building blocks of adding and subtracting and multiplication, whereas Singapore math is a concept, right? And they do like blocks and stuff. I heard Abacus is so good. Yeah, Abacus is really good. I have 3 boys and they all know how to do the Abacus. They've gone through the Abacus curriculum. They didn't go through my worksheets because as a young parent I didn't have enough time. But now they're older, I have more creativity. So everything that you see, like these activities that I show you here, these are all that came out of my brain. So yeah. So then I have this one where is the minus the 5, and that's the next one, right? Then after the plus the 5, and you might be wondering why do I break up the concepts? I break up the concepts because one, I didn't want it to make it to be too thick, but 2, I also wanted to have them have extra practice, right? Because I know that in mainstream math we give the children a lot of questions, but because it's so disorganized it's hard to logically think about math. So in Abacus we have a framework, but we also have patterns, and as you work through the numbers, as you work through the questions, you'll start seeing the patterns, and as you see the patterns you can go to the next level, if that makes sense. So and then after this would be the plus 10s, right? And I'm working on the minus 10s right now. So I realized that so here is a preview of what the minus 10s is. And we're going to be working through it. So that was the thing. Is the abacus method the kids use with their fingers? When I see the view where the teacher plays the... Yes, it is joyful. It is exactly what that is. When they start doing the gang signs... Oh, hey, Dreamy. Yes. Great. Yeah, when the kids start doing the gang signs, they're doing abacus in their brain. Some people know how to do abacus on their hands. I don't know. I don't teach that. What I teach is abacus on the abacus, on the soroban. Play a V long addition problem. Oh yeah, 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 yeah. And what it is, I mean, you could. How beneficial is it to have a very long? It's okay. Do I push it? I don't push it. I think for me, the longest one that I give you is 4 digits, because I think after 4 digits, it gets a little mind numbing, because there's more to it. But again, this is about solidifying a concept, right? Some of the kids are going through, and you see them on the video, they might go into competition. There is competition abacus. I don't push competition abacus. I'm pushing mainstream math. And so this is not an enrichment program. This is the fundamentals. This is building, filling the gaps, right? That mainstream math might be that the children might have. So we did that. Oh, somebody mentioned about the Russian abacus, the abacus that goes horizontal. So, as I said before, it is a 1-to-1. If you have one and you can modify it to make it in a soroban, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10. So when we're looking, it's just a 1-to-1. So it'd be like you just move. It doesn't matter which way you move. I don't know if there's a difference of weight how you move, but I would always go from like left to right. I don't know. So then there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you would have to count 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I don't know if somebody is still here that asked about that. And if you need to do modification. If you have this, you can modify to make it a soroban. It is up to you. I do provide that little bit of instruction. All right, so we're going to continue on. We are going to continue on. So we know how to add a 4, we know how to add a 3. So then what we're going to do is we're going to, thank you so much. Yeah, not a problem. That was interesting. I learned something new today because of you. Thank you. So, but yeah, there's a whole slew of things. It doesn't stop at just adding and subtracting. It does go to multiplication, division, but I don't think we're going to get to that. Neon, unless you had a question, unless you want me to think of some multiplication. How are we doing? All right, so the first thing we're going to do is understand our minus. Now, we added the 5. What we're going to do is we're going to subtract the 5. When we subtract the 5, we're going to understand that we need to minus the 4. Minus the 4. Why would do that? Because the question, remember, we're not going to memorize our digits. We're not going to memorize our numbers. What we're going to do is we're going to understand how to move the beads. So if my question is 8, and I want to take away the 4, to take away the 4, I know to take away the 4 is minus the 5 plus the 1. Hello, Audrey. Hello, Not So Pro. Welcome, welcome, welcome. You guys are so funny. Okay. So what are we doing? We have instructions right here. Oh, thank you so much. The hair chemist. Thank you so much. And you let me know if you have any questions. I appreciate that. Let me know if you have any questions, and I do offer. Oh, hey. That's been a while. Oh, there we go. Sorry, I have to do it. How do they not? Okay, anyways. Yeah. Um, and I do offer the abacus as well. The abacus, this one, or the 13 column one. For the older kids, I would do the 13 column one, and they can graduate. Yeah. Because then they can start doing multiplication division. That's like further down the line. But if they can go through it quickly, it'd be good too. So here, oh, sorry. So I have 8, right? And I want to take away the 4. To take away the 4, what am I doing? I'm going to minus the 5 plus the 1. These are now instructions, right? Minus the 5, and I'm going to plus the 1. That is 4. Does that make sense? So what we're doing is we're looking at our numbers. We're not going to memorize that 8, how to make an 8. What we're going to do is, can I take away the 4? So I just did is I learned how to take away the 4. You could do it again, right? So here we have 16. We have 16. And then we want to take away the 4. Notice there's not enough beads to take away the 4. What are we going to do? We don't have enough beads, so what are we going to do? We need to minus the 5 plus. So I'm going to minus the 5 plus the 1. You'll notice that there's a number pattern right here. So we have a number pattern. When we added, right, we added plus the 5 minus the 1. Now we're subtracting. That is now, right, that is now the number pattern. And it's very interesting because in Abacus we see the number patterns, whereas in mainstream math, I don't see it. Thank you, Colloquial. Thank you so much for reminding me. Thank you so much. Love the Abacus learning. Oh, me too. I enjoy the Abacus love. So we can do it again with the 4, right? When we do 4 and the 14. So this is another activity that was created where you have a paper clip, you spin it, and then wherever it lands, you put it either evens or odds. I try to make sure that I add a little bit of more categorizing. So if my abacus lands on 15, I add 15 on my abacus. And then what happens is I want to take away the 4. To take away the 4, I'm going to minus the 5 plus the 1. I'm going to minus the 5 plus the 1. So my final answer is 11. How often do you go live? I've been going live twice a day for, I don't know, has it been? It's been like 3-4 months now. Yeah, I enjoy going live to be able to get my sound bits going. I got some really good sound bits. I don't know, Audrey, can you hear this?
Hey, easy. Hurt people hurt people.
I think I gotta do that better. I don't like that one so much. So, I like my sound bits.
This is the way.
This is the way. This is the way.
Yeah. And so, oh yeah, so we're gonna do the minus 3. That's what this is. And then I give you examples how to minus the 3. When I minus the 3, right, here's the question. If I have 5, and I need to take away I have to do the takeaway, right? So I'm going to take away the 5 and add the 2. Notice that you do it at the same time like that. That's what it looks like. Right? Okay. Oh yeah, we're going to continue on. So we have 7. We have 7 on the abacus. We have 7 on the abacus. We're going to take away the 3. When we take away the 3, what are we going to do? We need to minus the 5 plus the 2. And again, this is what we see. Minus the 5 plus the 2. So my final answer is 4. Yeah? Neon! Any questions? How you doing? What's going on? What's going on? Okay. Anybody have any questions, or I'm just going to continue on just the path of understanding how to use the beads? How are we doing? What do we do? We did modifications? Oh yeah, we did modifications. Modifications! So we can do it again. So here's my question. We have 16, right? We have 16. And then we have minus the 3. Minus the 3, there's not enough. There's not enough beads to minus the 3. So what do? I have to minus the 5 plus the 2. Minus the 5 plus the 2. So my final answer is 13, right? Yeah, and that's the answer, 13. All right. And then there is tic-tac-toe, and then there's color by number, and then there's more spin the wheel, but this is for the minus 2, and then minus 1 doesn't have a lot of questions, but I have to sleep. Oh, joyful, yeah, thanks again, not a problem, I hope to meet you again. Yeah, I hope to see you in my next live. See you later, joyful, thanks for the comments. No problem, I see it. Cool. Okay, so if anybody else has any other questions, I can continue on, or we can go straight into multiplication. It is up to you guys. Or I can continue on with the Abacus curriculum. Because what I do is I go through the Abacus curriculum. And depending on how the class is, we can move all the way to multiplication. Because that seems to be very the thing. Or we can do division. Doesn't seem like there's a lot of people here. So we can move the class very quickly. I don't know if anybody else is here. How are we doing? We all right? Oh, I think the cheap, what is it? The cheaper town hall, I think, left. Hey, Mariah. Hello, Mariah. Okay. We could do a review. So let's review. Oh, yeah. Okay, review. Let's review. So the first thing we're going to do is we're going to understand how to read the abacus, right? So what we're going to do is we're going to understand this, that this is 1, and then we have 1. Why am I doing this? The reason why is because I'm using the money to help you relate that this is 1 on the abacus and this is 1 penny, right? If I did 2, then I would be 2 pennies. And then if I did 3, it'd be 3 pennies. It doesn't matter what the order is, right? It doesn't matter what the order is. Same thing with the abacus. It doesn't matter what the order is. And then this is 4. So now I have 4 pennies. And that's it. If the beads... But then when we look, how do you get 5? Well, 5 will always be the top bead. 5 is the top bead. That is what 5 is, right? That's what the 5 is. So then when we add 6, how do we make 6? That's how we do 6. 5, 6. And then we have 7. 5, 6, 7. And then we have 8. 5, 6, 5, 6, 7, 8. And then 9. 5, 6, 7, 8, 9. That's it. That's how you read the abacus. Wow, thank you guys so much for liking the live. I can't believe people get to like 1,000,000 likes. I'm like, oh my god. That's it, Mira? Come on, there's gotta be more questions. Like, how do you make a 10? How do you make a 10? And making a 10 is like that. That's how you make a 10. How do I know that that's how you make a 10? I make a 10 because every column is a place value. So if I show you a label, that's how I label it. Ones, tens, hundred, thousands, 10,000s. So when we're looking, we have our 10, and then now we can count by 20s. Now we can count by 10s. 10, 20, 30, 40, 50, 60, 70, 80, 90, and then 100. So if I did this, this is actually 2 5s. This is 55. This is not 10. 10 looks like that. Because why is 10 like this? Because it's a 1 and a 0. Right? A 1 and a 0 is what 10 looks like, not 2 5s. So exactly how we write it is exactly how we read it on the abacus. When we have this number, this would be 510. Yep. And then when we look, we have 600, right? 610, 710, 810, and 910. And then we have 1,000. So every column that you see, every grouping is worth number groups, grouping numbers, right? So when we're grouping the numbers, right, this is our ones, this is our thousands. But if but excuse me, like a Pokemon,
I choose you!
if you choose this one, then this can be your tens, and this this can be your ones, and this can be your tens. But then you have all of this numbers over here to be your decimals. But that's why. But I choose.
Okay, Charizard, I choose you!
But I choose this one to be my ones. So then I have a lot more numbers to be my digits. Yeah. All right. So how are we doing? Yeah, not a problem, Mira. Thank you so much for joining. Okay. How are we doing? Miracles and money. Welcome. Welcome. All right. If there's any other questions, I mean, we can continue on with adding and subtracting. So the next thing we're going to do is we're going to understand. I don't know who else is here. There's about 15 people in the room, but I'm not sure who else is here. The one thing that we're going to do is understand that what? When we use the abacus, you don't want to be aggressive. You don't want to be aggressive, right? The reason why is because the abacus is very easy to move. Because the abacus is very easy to move, you want to just use your fingers and be gentle, right? You want to be gentle. That's all. We want to be happy and we want to be gentle when we're using the abacus. Teaching us for the abacus. Oh yeah, you're welcome, Heba. I didn't see that you were here. So when we're looking at it, right, we want to be gentle when we use the abacus, right? And it's like a little rattle. And it's also notice, what is that? Oh, hey. That's cool. Also notice that it's very easy to move. So you want to use your left hand to stabilize the abacus. So we use our left hand to stabilize our abacus, and we use our right hand to do the calculations. Because we use our right hand to calculate, I think it's because our left hemisphere does the calculations. You want to use your left hand to secure the abacus. You want to use your left hand to secure the abacus. So the other thing is also notice that if I have math time, hey, user 188. Did you get the rain? No, we didn't get rain today. We didn't get rain today. It's been sunny. Let me take my dog out. Oh, please. She can be so annoying sometimes. Yeah, no. I'm in Southern California, so I didn't get rain. How's the teaching day? Teaching's been good. We just started reviewing again, not repeating, reviewing how to move the beads and stuff. We were going to go into multiplication, but then people started showing up and then they all got confused. Other than that, it's been good. I've been on for a little bit, so I don't know if Neon is here, but I know Alma came and left. But yeah, everybody seems to be interested in the abacus, which is kind of cool. Yeah, but thank you. I appreciate that. So, anybody have any questions? Adding and subtracting. Yeah, let's. Do you want to do some adding and subtracting right now? Okay, so let's do that. Let's do that, and let's see how far I can go. All right. So the first thing we're gonna do. So do we need to review counting to 10 and the place values? Let's go. Okay. So miracles. Did you want to do adding the 10, or did we want to go back to adding or subtracting the 5? I don't remember where we left off. Or did we start with the tens and we started doing two-step equations? I should write these down. Whatever you think best. Well, I don't remember where we left off, so I'm just kind of gauging. Oh, we can do that. Okay, let's do some times table. That's an easy one. All right, let's do some times table. So we could do that one. So we have 131 times that by 4. This will be easy. Why? Because what we're going to do is we're going to look at our digits. When we look at our digits, what we want to do is we want to count it, right? When we're counting our digits, we do 1, 2, 3, 4. 1, 2, 3, 4. We know we're going to be here somewhere, right? Reset the bar first. Yes, thank you. So we're going to count here first, right? Because we're going to be here somewhere. So, and then what are we going to do? Well, we do distributive property, right? Distributive property is what? Distributive property means that we're going to go from here to here. So what we do is we do 4 times 1. Notice 4 times 1 is a single digit. 4 is a single digit. Because 4 is a single digit, how do we make this into 2 digits? We need to do what? We need to add a 4 and a 0. So we know we're going to do 0 and 4 over here. So the 4 goes over here. Now what are we going to do? We got to do 4 times 3. Yep. 4 times 3 is equal to 12. When we add 12, what do we do? We need to add the 1 and we need to add the 2. Notice when I do 4 times 1, right, we don't say 4 times 100. It will equal to 400. It already shows me on the abacus 400. It already shows me on the abacus 400. So we just need to make the multiplication fact. Now we're here. We want to add the 1. To add the 1, how do we do it? Do we have enough beads to add the 1? No, we don't. What do we do to add the 1? It's recounting of the digits. How do we add the 1? Thank you, user. Thank you, user 814. Right? So what we're going to do is we're going to do plus the 5 minus the 1. Sorry, minus the 4? Yeah, because we need to add the 1. So plus the 5 minus the 4, right, equals to 1. And then here we're going to add the 2 because we added the 2. So we're done with that. What's next? 4 times 1. 4 times 1 is 4. We go 4 is a single digit. We go back to 4 and we add the 4. And that's it. So my final answer is 524. Why did you start on that row? Yes, ma'am. I started on that row because because I needed to count my question, the amount of digits I have in the multiplication. I need to count it so I know how big my answer will be. That's why. Yes, you need to count these digits. Thank you. When you count the digits, then you know roughly how big your answer is going to be. So this one says my answer is going to be maybe 1,000, but it turned out to be only 3 digits. It looked like it was going to be 4 digits, but it actually turned out to be 3 digits because we had single digits. Yeah, it gets interesting in how Abacus was able to break it up into smaller chunks. But I do like it because now instead of saying 4 times 30, right? Instead of saying 4 times 30, 4 times 30, right, would equal to what, 120? We don't need to keep track of that. Oh, I shouldn't do that. We don't need to keep track of that. Well, why? Because the abacus does it for me. The abacus does it for me, so I don't need to do 30. I just need to do 3. Would this abacus be good to teach remedial students? I believe abacus is great for everybody, not just for remedial students. Remedial what? Algebra? No, remedial like interventions, math intervention. I think it'd be great. I think it'd be a really good stepping stone for the kids that are maybe that's where it starts. But I do believe it's underperforming. Yes, underperforming students. Yeah. Intervention. Yeah. Do I? I don't think it's only for remedial students, but I do believe it could start from there and then work its way through mainstream school. So the reason why is because I mean we have all these other math manipulatives, right? We have all these math manipulatives. We do box and arrays, right? And we do the 10 frame. We do all of these things to picturize, to picture what we're trying to do, whereas the abacus does it for us. Is it too complicated? It's a different way of thinking. It's a different way of thinking. It would require a little bit of teaching, like just as I'm teaching you now, right? Like how to read the abacus is one way. How to understand how to move the beads is another way. So it reintegrates the theories for students who are failed and not taught. Yeah. No. Only yeah. You only need to know 0 to 9. Yeah. She shows analog with the cubes and the coins. Yeah. But I don't. I don't. I mean, this itself is this itself is very difficult because then don't forget you have to do trade-ins and stuff. Whereas on the abacus we get formulas, and we tell the kids that they need to learn certain things, but there's not a lot of strategy. There's a lot of critical thinking. Important to buy an abacus and practice during the live. Yeah, yeah. But if show the principal. Oh, yeah. Okay. So thank you, thank you. So, Principal Martin, when we're looking at it, just to read the abacus, we do 1. So, I'm going to do 1. That's 1, right? If I do 2, this is 2. If I do 3, this is 3. If I do 4, this is 4. Now, what's going to happen is I want 5. 5 looks like this. 5 looks like that. Notice I take away my 4 beads, right? And the top bead will always be 5. And then we have 6, that's 6. We have 7, that's 7. We have 8, this is 8. And then we have 9, and this is 9. And then what's 10? 10 looks like that. Just like this. This is my dime, right? My dime is 10. So that's what it is. And then you can count by tens. 10, 20, 30, 40, and then 50, 60, 70, 80, 90. And then it goes further, right? The green one, yeah. Yeah, exactly. So 10 looks like that. And then we do 100. 100, 100. That's what 100 looks like. Why? Because we have our place values, our placeholders. Our hundreds are our placeholders. So when we're looking, we have 100, 200, 300, 400, 500. So again, you focus on the result, not focus on the result. Oh yeah, thank you. I gotta find it. Hold, please. Oh, here it is. Yes, thank you for the reminder. So yeah, here we go. So we have our ones, or tens, or hundreds, or ones, tens, hundred, thousands, and 10,000s. So every column is a place value. Every place value has 9 digits, just like how we write in math. You're amazing. Oh, no. Thank you so much. I appreciate that. But yeah, I mean, I forget, like, if it's in the middle of the, because I've been on for a little bit, so I forget, like, the beginning parts. So, what sort of, Principal Martin, what sort of, how old are the kids are you looking at that would need help? The intervention. Is it complicated? It's not complicated, it's just a different way of thinking. Oh, I think Principal Martin had left. Okay. Um, yeah. So we have, okay, we have that, we have that. What are we doing? Oh, we can do this. Oh no. Hey, there you are. Good for the brain. Oh, you're still here, Principal Martin. Good. Well, what other questions do you have? Oh, good. I'm happy you're still here. Because it's through this. So here's more. Yeah. So how old are the kids that you're? Because it depends on how. I mean, obviously, it depends on how you talk to them. It. If they're young, is this base 5? No, this is a 10 base because it's digits. It's the decimal system. So we have the decimal system, right? We have our ones, our tens, our hundreds, and then here's my decimal. My decimal sits between my ones and my tenths. So here's my decimal, my ones and my tenths, and then I have my hundreds. So base 5 means that you can only go up to 5, whereas base 10 is what we're doing. Our number system is base 10. I don't want to jump around. Maybe we see addition with regrouping. Oh, yeah, okay. Addition with regrouping. Okay, let's do that. So there's a few concepts that we need to understand. I see that, but the parts you're moving are given. I see that, but the parts you're moving are given. What do you mean by that? The parts are moving are given. We'll do 6 plus the 4. No, 6 is tough. 6 is a little tough. We'll do 7. We'll do 7. Count to give. Give a numerical example. The columns total to 5. No, the columns total to 9. 5, 6, 7, 8, 9. 6 requires 2-step normally. Yeah, 6 does require 2-step normally. Thank you. Is that Melinda? That's not Melinda. Because I don't see your username. I don't see your, yeah. Okay, thank you. So when we're looking at it, right. So when we're looking at it, yes. So we have 62, 185. So let me rewrite it, right? So 62, comma, 185. Now if you notice there's a comma here, because there's a comma, I have a comma here. So when I look, I do 62, 185. That's what that would look like. Okay. So, okay, yeah, I think it's, yeah, your picture doesn't show up, Melinda. I didn't know that was you. I always see your picture. Okay. Is using the Abacus applicable to real life, like daily usage? I don't know. It depends on what you're doing. Are you teaching? Oh, okay, Principal Martin. Go, yeah, head to bed. What's my live schedule? Usually in the morning and usually at night. So, I'm in Pacific Standard Time, so I'd come on like about 8 o'clock in the morning and then 8 o'clock at night. Depending on your usage, yeah. Yeah, so it is, Melinda. Hello, Melinda. Sorry. Yeah, I don't see your picture. It is after dark, sometime morning, usually noon Pacific. Yeah. Mm, I've been trying to make it more morning now, like 8 or 9 in the morning. Trying to get the what do you got the homeschool people. But yeah, no, Principal Martin, you can you know what? You can DM me if you want to have a better conversation than just go through live. Um, we could have a kiss. Yeah. Yeah, Principal Martin, if you want to just DM me, we can have a conversation on the side note. You don't have to wait for my lives. I am open to trying to bring this into more mainstream school and teaching the teachers, because I do realize it's an investment, right? To change the way we think. And I know there's a second grade teacher that I know, and he wanted to introduce the abacus, but the problem is we're focusing on the result and not the add-in. We're not focusing on how do we get there, and that's a whole mindset that we need to kind of walk through first. Hey, ka, like bruh, but with a K. Yeah, yeah, yeah. Send me a DM and we can have a conversation. We don't need to be on live to do that. But yeah, if you have very specific questions, I don't have a problem with that. Cool. Yeah, go to bed. Principal Martin, go to bed. Have a good night. We're good. Simple math with regrouping. Yes. Do we want to do this one? What are we doing? Are we okay with this one? So we have 18. We have 18. 1 and 8. 8. We have 1 and 8. So we want to add the 7. To add the 7, what are we doing? Oh no, that's the wrong one. Add the 7. We know this. Woo, woo, woo. We want to add the 7. Can we add the beads? No, we cannot add 7, right? We don't need to add the 5 because 7 doesn't do 5, right? So we have to go down to the 2. To go down to the 10. Can we add the 7? Yes. Plus the 10 minus the 3. So we're going to plus the 10 and then take away the 3. That's it. So my final answer is 25. Yeah. We can do it again. We can do 14. We can do 14? No. Oh no, we can do 14. Oh, we can do 14. Yep, we can do 14. Right? So then if we do this one, let's do 14. Let's do 14. So if I had 14, right? I have 1 and I have 4. 14. And then we're going to plus the 7. To plus the 7, is there enough? No. There's not enough to plus the 7. So what do we do? Right? We need to plus the 10 minus the 3. So we're going to plus 7 is equal to plus the 10 minus 3. Minus the 3. So we're going to plus the 10, right? 10 looks like what? 1, 0. 1, 0. We're going to add the 10. And then we're going to take away the 3. So we take away the 3 here. So my final answer is 21. Yeah. Yep, yep, yep. Yep, 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 yep. So when we're looking, right, 3, 7, 8, we can do 8 again. You want to do 8? Let's see how this goes. So if we do this number, we do 2 on the abacus. We're doing this one. We do 2 on the abacus. And then we add 8. Is there enough beads to add the 8? No. There's not enough beads to add the 8. So what do? Plus the 10 minus the 2. So we're going to plus the 10 minus the 2. And then we add 7. Add 7. So my final answer is 17. Yeah? We do this one, right? If we do 6, We do 6 minus 3. Can you take away the 3? No, we cannot. Is there enough beads, right? No, there's not enough. Can we take away the 5? Can we take away the 5? Minus the 5 plus the 2. Minus the 5 plus the 2. And then plus 8. You need to add the 8. Can you add the 8? Is there enough to add the 8? No. So we're adding the 8. So we have to go here. We add the 8. To add the 8, what do? Plus the 10 minus the 2. So what are we doing? Plus the 10 minus the 2. So my final answer is 11. We'll do it again. We can do it again. So here I have 4. We have 4. I want to add another 4. To add a 4, can I do it? Nope. So what do? I go down here. I need to use the 5. Plus the 4 is equal to plus the 5 minus 1. So I plus the 5 minus the 1. And then I need to add the 8. I'm going to add the 8. Is there enough to add the 8? No, there is not enough to add the 8. So what do? I go here. To add the 8, I have to plus the 10 minus the 2. So I plus the 10, and I take away the 2. So my final answer is 16. Cool? Thank you, Melinda. Thank you for all the hearts. Yeah? Excuse me. How are we doing? We're all right? Want to do another one? Okay. Let's do this one. We have 2. That's easy. We'll add the 2. Then we have the 5. That's easy. Do we have enough? We have enough.
Yes, we can!
So we add the 2. We add the 5. So then we have to add the 8. Right? We have to add the 8. So what I was trying to do here was focus in on the adding of the 8. Right? So we have plus the 8 is equal to plus the 10 minus the 2. So we plus the 10, and we take away the 2. So my final answer is 15. Yeah, you're welcome. You're welcome. You're welcome, Miracles. So because when we're doing, it's just one of those things to make it a little bit more consistent. Because we should know how to do these numbers. Right? That is regrouping of adding. We can do minusing, but I don't have it ready though. Oh, what are we doing? We're doing this one. Yeah, we're doing this one. It's a plus 10s. Yeah. Oh, okay. How are we doing? I'm going to head out. It's been a little bit. Anybody have any questions? Eliana, did you have any questions? I see that you're watching. Yeah, no problem, Miracles. Thank you for encouraging me to like go through the questions. I feel weird when I go through abacus questions just because I don't know, like I'm just doing math. I don't know. You know what I mean? Like I feel I know it's good, but I feel weird to just keep going through. I don't know. I know it's just me, and I know it's helpful, but I appreciate that you encourage that. You know what I mean? Like, thank you. I appreciate that. I appreciate you keep asking about making more, because I don't know. I feel I'm still trying to figure that out. But I appreciate that I appreciate that you ask for those questions, and it's helpful. So I do appreciate that. Thank you. All right. Yeah, I didn't get to do. I got a little bit to do multiplication, but that's okay. That's okay. All right. So I don't know if Melinda is still around. Apple user. That looks very familiar. Okay. I don't know if anybody else is still around, but I am going to sign off. I am going to hit the sack, and it's been a little bit. So let me know if you have. Do you have any more questions, Miracle, before we end the live? But I appreciate you joining. Yeah. Are we okay? Oh, okay. All right. So we're okay. If that's okay, then I am going to end the live if there's nothing else. Have a good night, everybody. Have a good evening. Have a good morning. Have a good day. I will see you guys all in my next live. Bye.